Alright, so if we're gonna set this problem up for number 4, it says Tony purchased a rare 59 Les Paul in 2000 for $12,000. Experts estimate the value will increase by 14% a year. That's a lot. In what year will the value of the guitar be worth $60,000? So, guys, this is real. You can use these formulas anytime you want. And even if later in life you don't have them memorized, just the idea of knowing you can calculate this kind of stuff. You can Google the formula in just a second, right? Okay, these formulas are accurate and they work all the time. People use them all the time. So let's try this one. So for number 4, we know that currently, or we want it to be worth $60,000. So we're going to use our 60,000, and then its original was 12,000. It appreciated, so there's your 1 plus. And we're going to turn 14% into 0.14. And our time is what we don't know. We don't know how long it's going to take. And you can use that for like a stock portfolio or your interest, or let's say you want to buy a car and you started saving young and you know what interest rate your bank account makes. You know, how long will it take you, to reach a certain value? So to solve for t, this time guys, t is a variable. We haven't done one of these like this. So I'm trying to get t, which is up here by itself. So the first thing is to get rid of the 12,000. So divide both sides by your 12,000. Okay, which gives you 5 equals to 1 plus 0.14 t. Now, if you would like to go ahead and simplify this 1 plus 0.14, and change that to just 1.14, in my opinion, sometimes it can be a little easier, especially on this kind of problem. Now, if I'm trying to get t by itself, what do I have to do to both sides? How do I bring t down? What have we studied? Yeah, logs. Log both sides. Okay? And then the property of work. If you take log of 5 and you take log of 1.14 to the t power, what happens to this t? What can I do with it? It pushes it to the front. Now I know we're not used to having the variable on the right side, but the idea is the same. So I have a log of 5 equals t times the log of 1.14. So if I'm trying to solve for t, and I ran out of room, so I'm going to bring it up over here. I'm trying to solve for t, then t now equals, okay, if you left t on the right side, you're going to have to bring this log 1.4 to the other side. So you have log base 5 divided by log 1.14. I'm sorry, log 5 divided by log 1.14 equals your time. And what time did you get? 17.25 or 26, depends on your rounding. Try to round as little as possible. The more you round, the more inaccurate your answer is. Yes?
I got 12.28.
Yeah.
Did I look at the wrong? Oh, I'm sorry. I looked at the wrong problem. 12.3. Is that what you got? Okay, yeah. I'm sorry. That's the answer to the next problem. I apologize. Thank you. Did y'all get 12.3 years? Okay. But the question was, in what year that will be? So what year is that? 2013, right? If it's 12 years and 12.3 years, it's 12 years and 3 months, right? So in what year is that? 2013. Does that make sense? Right? If I need to be, it says in what year will it be worth $60,000? Well, in 2012, it won't be there. It takes 12 years and 3 months, which would be 2013. All right, number 5. Thank you back there for the help on that one. Sorry. Okay. The value of a truck bought new for $28,000 decreases 9.5% each year. What will the value of when will the value of the truck fall to $5,000? So there's another time question. All right, I want to know when it is. So the price that we're talking about would be $5,000, because that's not the original, is it? The original always goes on the right side of the equal sign. And then 1 minus, because we were depreciating, 0.095. And then there's your time. So So the first step would be to divide both sides by your 28,000. And I got 0.1785. And I'm gonna go ahead, guys, since we're solving for t, I'm gonna clean this up and write, if you do 1 minus 0.095, you get 0.905. So I'm gonna change this to 0.905t, because I think you'll be able to see it easier. Now I want to, all I did was divide both sides by 28,000, right? And I cleaned this up a little. Did y'all see what I did? Okay, so I need to solve for t, and t's an exponent, so we're gonna log both sides. So the log of 0.1785 equals the log of 0.905t. Remember that t gets pushed in the front. So you can put the t there if you want. And to solve, you're gonna divide both sides by log 0.905. And then time equals, and that's the answer I got earlier that I made a mistake with, I'm sorry. 17.26 or something like that. Years. Which is approximately 17 years and 3 months. Okay, so now we're gonna switch to a different formula. We're gonna skip number 6 because of time. And we're gonna switch to compound interest. You see that one? Okay, guys, this formula is almost exactly the same. You still have the A, which is the new amount. You got the P, which is your original amount, and you have a 1. But instead of 1 plus R, there's this extra N, and it's here and here. You see it? So whatever N is written 2 times. Okay? And N just represents, this is more real life, guys. When you borrow money or when you save money, they don't wait till the end of the year to calculate how much interest you have. They calculate it all the time, right? And if you're saving money, you want them to calculate it as much as possible, as many times per year as they're willing to do. Because the more they compound the interest, the more money you get, okay? If you are borrowing money, you want them to compound it as little as possible, okay? Because same thing, it costs you more money, right? But in reality, this is more complex of a formula. It's more real. The other one is a very simple formula. To give you a general idea, this one's more complex. It's more accurate, okay? And so let's look at it. This still represents the same. Okay, the A is the new value, just like it was before. The P is the original amount, same. R is still the rate in a decimal form. The only thing that's different is the letter N, and it appears in 2 spots, right? Here and here. And it's just how many times you compound per year. Compound just means calculate. How many times do you calculate it each year? You calculate the interest. So let's try number 1. It says an investment account pays 4.2% annual interest, compounded monthly. How many times, if you compound it monthly, is that per year? So compounded monthly means 12 times per year. Okay. It says if $2,500 is invested in the account and left to accrue interest, accrue just means earn, so earn interest, what will the balance be after 15 years? Okay. So do we know the new value this time? No, we don't know. That's what we're asking for. In 15 years, how much money is going to be there? Did we know the original value? Yes, I put $2,500 in the bank. Okay, it's earning money, so that's a 1 plus, and the rate is 0.042. Remember, turn it into a decimal. But the 0.042 this time, because we're compounding that 0.042 every single month, you don't just put 0.402, you put 0.402 divided into 12 times. Do y'all see that? The formula calls for divided by n. And then you raised it to the power, not just time, but 12 times, how long was it, 15 years? 12 times 15. 12 times every year times 15 years. Because your A is on the left side, you can just type this straight in your calculator. And you might want to try it to be sure you're getting the right answer. But I got $4,688.87. So their $2,500 turns into almost $5,000. Okay, if you didn't get that in your calculator, if you didn't get in your calculator, you're not entering it incorrectly.
Okay.
So if you want to try it, you're going to do 2,500. I don't know if you can see that calculator. Okay, open parentheses, 1 plus, and then I don't know if any of you use the alpha. I hit the wrong button. Oh, your calculator doesn't have it. Okay, so if you don't have that feature, then right here, you want to put this whole fraction, so I'm going to open parentheses and put 0.042 divided by 12 and close my parentheses. And then close it one more time. Right, you see what I did? I just entered this part in. So I did 1 plus, open parentheses, I typed this fraction in, and then reclose that set. And then I'm going to raise to the power of your 12 times 15. So I'm going to open parentheses, 12 times 15. Close parentheses. You see how to do it now? Anybody else need help with that? Okay, so now let's go to the next problem. Marta opens a bank account with compound interest. It will tell you if it's compound. If the problem says, hey, it is compounded annually, compounded biannually, whatever, okay, that's when you know to use this more sophisticated formula. The first formula we did was simple interest, this is compound. The way you know to tell the difference between the two would be if it tells you in the problem, okay? If it doesn't tell you it's compounded, then you just use the easy formula. She deposits $2,200 and leaves the money to accrue for 5 years. The account is compounded twice a year. Okay, so how many times is it compounded per year? 2, right? So let's go ahead. She earned a total of $1,056.54 in interest. Okay, now guys, do I know the new value? They didn't come out and shout it, but do we know it? Yeah, we have to add the two together, don't we? She earned this much in 5 years, and she started with this. So to find the current value, you have to add those two together. So that's going to be $3,256.54. And her original was $2,200. It earned interest, so that's 1 plus, we don't know R, divided by twice a year, so you're going to divide that by 2. And you raise the power of how long? 5 years times 2, so 2 times 5. That should be 2 times 5, and as the exponent. Now, to solve for R, you have to get rid of all of this mess over here. What's the first thing we're going to do? Divide by the 2,200. So divide the whole thing by 2,200. And you get 1.48 equals 1 plus R divided by 2 to the 10th power. I just multiplied 5 times 2. How do I get rid of the 10? I'm trying to solve for R, right? So I've got to get rid of all this, and we get rid of the 10 first. How do we get rid of the 10? Good, raise it to the 1/10. Both sides. So I got 1.040, I guess, equals 1 plus R divided by 2. What's our next step? Subtract 1, then times 2. Subtract 1, and then times it by 2. So you get 0.08, which is 8%. Okay, so we have one last formula. And this formula is used in science. It's half-life. Have you guys ever seen that project that some of the science kids have done before, where they make a big project board and it tells you how long it takes things to decay, like aluminum, plastic water bottles, styrofoam, right, trash bags, all that kind of stuff. It's kind of interesting when you look at that, how long it takes things to decay, okay? And that's what this formula calculates. In other words, that's how they found out how old the pyramids were, right? Or how long it takes that water bottle you're gonna throw away tomorrow to be off the earth, right? It's that kind of thing, okay? It's half-life. And it's called half-life because that's how it's calculated. In other words, how many years would that water bottle take to be halfway gone, okay? So and then you calculate it over and over, okay? Now, the half-life of a certain substance, and what they mean by half-life is how many years will half of the life be gone? In other words, if you have a box that's this big, and I tell you that in a year, okay, this much of the box is gone. So now it's been 1 year, and I've got that much left, right? In another year, half of what's left is gone. So now in 2 years, I've got this much of my box left. I'm in 2 years. So now in this, I've got 3 years, and that's how much I have left. This would make 4 years, right? And then 5 years. Realistically, in 5 years, I've got this tiny little sliver of box left. And it just depends on the object, okay? So if you look at the half-life of a certain substance, it's 3,000 years. Here's my formula. All right, let me tell you what they stand for. The same as before, the first one is the new amount, And this O underneath here stands for, what do you think? Good. The 0 just stands for the original. In other words, this is the original amount. And it's half-life formula, so there's your 1/2, right? And then the T, this is where it gets kind of weird, okay? This is the time. In other words, how long is it gonna take for something to go away, right? And the bottom one is the half-life time. In other words, how long is its half-life?
And things like this, is the time always going to be measured in years? Like what I'm doing?
No, you'll see. It's all kinds. Sometimes it's minutes, sometimes it's hours. Yeah, good question. And you'll see that when it comes up actually in this problem. So let's try it. The half-life of a certain substance is 3,000 years. Guys, that's crazy. Okay, so it's meaning that if you have 100 gallons of something, it takes 3,000 years for there to only be 50 gallons. Okay, it takes a long time. So is 3,000 years. Determine how much of 150 kilogram of substance will remain after 9,000 years. So 9,000 years, how much will be left? Right, so if we do the formula, we do not know the new amount. That's my question. The original amount was 150 times 1/2. And the formula stands for time over half-life time. Well, how long is our time? 9,000 years, right? What's the half-life time? What did it say? It said it was 3,000 years. Now guys, type this straight in your calculator. Mistakes kids were making today was they were trying to take 150 times 1/2 and then raise to that power. That's not what it's wanting. Type it in just like it is. Actually try it. You want to be sure you're getting it right. Because the answer is after 9,000 years, you'll still have 18.75 kilograms. If you start with 150, you'll have 18.75 in 9,000 years. It's crazy. And then you have the next one, which is really weird, because it's a radioactive substance that's half-life is 40 minutes, really quick. Every 40 minutes, half of it's gone, right? Thank goodness if it's radioactive, right? Okay, this is how much of a 3,000 milligram sample remains after only 2 hours. Good question. She said you have to convert. Absolutely. You need to use the same unit of measure. All of it hours or all of it minutes. Well, since this is minutes, let's convert hours to minutes, which would be 2 times what? How many minutes are in an hour? 60. Okay, so you're going to use 120 minutes here. Do we know how much is left, the new value? No. We don't know that. That's what we're trying to find. But we know that 3,000 starts with half-life. It's time over half-life time. So how much time are we gonna process it? 120 and its half-life is 40. Type that straight into your calculator. And if you did it right, it'll be 375 milligrams. So we have one last problem. We're gonna do number 11 and we'll be done. Questions on 10? Okay. I know there's 11 and 12. We're just gonna do 11. It's misnumbered, I'm sorry. It says 12. We're gonna do this problem right here. And it looks like it's 12 and 14, but it's not. That's carbon 14. It just happened to end right there, so it looks strange. Okay, a paleontologist uncovers a fossil of a saber-toothed cat in Bexar County. He analyzes the fossil and finds the specimen containing 15% of its original carbon-14. Okay? Carbon-14 has a half-life of 5,730 years. Alright? This is how they analyze the pyramids, right? Carbon-14 dating. So use carbon-14 dating to determine the age of the fossil. Okay, so let's think about this one. It's kind of strange. It gave me a half-life time, and it gave me the percent that was left. What percent was at the end of when he found it? How much of it was there? 15%. So as a decimal, we're going to use what? 0.15. Well, when the saber-tooth was alive, what do you think his carbon-14 would have been? 100%, right? He'd have been there. So that would have been like a 1. Okay, we're going to find half-life, so there's your 1/2. And it's time over half-life time. So do we know the time? That's what it's asking, isn't it? What's the time? How old's the fossil? We don't know T. And what's its half-life time? 5,730 is half-life time of carbon-14. What's my first step? Divided by 1, which doesn't do me any good, right? So you're left with 0.15 equaling 1/2 times T divided by 5,730. How do I solve for T when T is an exponent? What are we supposed to do to both sides? Log both sides. So I'm going to start it up here so I have room. So I'm going to log the 0.15, and I'm going to log the 1/2 T divided by 5,730. What happens to an exponent when you log it? The property allows you to bring it to the front. Right? You're allowed to take this whole thing and bring it to the front. So now you have log of 0.15 equals T over 5,730 log of 1/2. We're not really used to having the T on the right side, but that's okay. Here's your T. What are you going to do to both sides to solve first? You're going to divide everything by log of 1/2. So log of 0.15 divided by the log of 1/2. Yeah, I got 2.73. So 2.73 equals T divided by 5,730. So multiply both sides by 5,730. And how old was that saber-tooth? At 283, is that what you got? Oh. Okay, and that's done for the notes. We're going to stop there.